Okay, so today we are talking about the area of triangles and similar polygons. And before we can talk about the formula for the area of a triangle, let's talk about some of the sides here. So we want to talk about the base and the height, and the base and the height are always going to make a right angle. So in the first example, we would have a base and a height. Notice they make this right angle right here. In the second triangle, we have a base, but we don't have a height because there's no right angle. But if we draw in here, where this would be a right angle, this is your height. So sometimes your height is going to be one of the legs of the triangle. Sometimes your height is going to be inside the triangle that you're going to have to draw or find. And then sometimes it can even be drawn outside of the triangle. So this would be the height. Now your base is still just this side of the triangle, but this is your base and this is your height. Okay, so with that said, we have the area formula for a triangle, and the area formula is 1/2 base times height. Now some people like to write it as base times height divided by 2, and that is the same thing. You can do either way because multiplying by 1/2 or dividing by 2 is the same thing. Okay, so in example number 1, find the area of the triangle. So we have area equals 1/2 base times height. So we have 1/2. Here's our base, here's our height. We know that they are base and height because of the right angle. So times 10 times 6. So if we have 1/2 of 10, that's 5, times 6 is 30 centimeters. Remember, area is squared, so the area of this triangle is 30 square centimeters. Example number 2, use the triangles below to complete the following. First of all, why are the triangles similar? Remember, we have 3 options: angle-angle similarity, side-side-side similarity, or side-angle-side similarity. Here, we are going to test side-angle-side similarity because we have 2 pairs of sides and the angle between them. So we already know that the angles are congruent because they're both right angles, so we just need to make sure that the sides are proportional. So is 4/8 equal to 3/6? Yes, because they both reduce to 1/2. So why are the triangles similar? Side angle side similarity. If you recall what scale factor is, it's just the ratio between the 2 sides. So when we reduce that, we got 1/2. So the ratio of triangle A to B is 1 to 2. If you said 4/8, that's also correct. It's just not reduced. So what is the ratio of the perimeter of A to B? If you recall, the ratio of the perimeter is the same as the ratio of the sides, so that is 1/2 as well. Okay, so let's talk about the area. Remember, area of a triangle is 1/2 base times height. So for the first triangle A, the base is 3 and the height is 4. 3 times 4 is 12, and 1/2 of that is 6, so we have 6 meters squared. The second triangle, triangle B, area equals 1/2 base times height, so 6 times 8. 1/2 of 6 is 3, times 8 is 24 meters squared. Okay, so if you now look at part D, it says what is the ratio of the area A to the area of B, and what do you notice? Okay, so the ratio of A is 6, or in the area of B is 24. So we'll reduce that, and we see that it is 1 to 4. So it is not the same as the ratio of the sides. It is not the same as the ratio of the perimeters. It is a little bit different. So let's talk about how it is different. If 2 polygons are similar with a scale factor of A to B, then the ratio of their areas is actually A squared to B squared, which makes sense because all the units for area are square units. Okay, so let's test that above. If you have the ratio of the sides, which is 1/2, if you square that, remember that's just 1/2 times 1/2, And when you multiply fractions, you just multiply straight across, which gives you 1/4. And that is indeed the ratio of the area that we found. So in symbols, if ABCD is similar to EFGH with a scale factor of A to B, again, the area of ABCD over the area of EFGH is just A squared over B squared. Perfect. All right. Example number 3, find the scale factor of triangle ABC to DEF. Notice they're giving you a certain order, so we are going to use this triangle first, then this triangle. We want corresponding sides, so I'm going to say 2 corresponds with 3. That's the ratio of the sides. We call that the scale factor. Or you have also called that K, either way. So then what is the ratio of their areas? Well, we need to square that, so it would be 2/3 squared. And again, when you square something, that's 2/3 times 2/3, it's just multiplying it by itself. And when you do that, you multiply straight across and you get 4/9. This is the ratio of their sides. This is the ratio of their areas. Checkpoint. 1, 2, 3. That's what you're responsible for.